Hello students. Yesterday I thought I should not do this one now, but I think it is better to do it once more directly after the other chapters we have done. And so I want to do chapter 3.5, the geometric functions. And then I want to define them and also calculate their derivatives and all kinds of other things of it. One thing, just what is the cosine, what is the sine, and what is the tangent of something. If you have the plane, xy plane, so the axes perpendicular to each other, then you can have some point A, B, A for the x direction, B for the y direction. So you have here the A for the x direction, B for the y direction. You can make some vector of it, so you can make some, you can have a line between the origin and that point AB, so you get some line with a certain direction, and that line makes some angle phi with the positive real x-axis. So with the positive, if you look to the x-axis, you are on the where the x is positive, then you can look to the angle which that arrows made, that vector makes with that line, and that gives you the angle phi. Now, what can we do? Phi, the angles always we will always measure in radians, and be careful with that. So don't use degrees or something like that. Use always radians, because that is you have no dimension. That phi is then dimensionless. And what is the case? Now you have from the point AB goes to some through some circle, and here you have the circle x squared plus y squared is e squared plus b squared. That is the circle where the point is on, and then you can measure the distance from the point on the positive real axis to that point AB, and you can divide it by the length of that arrow, and I said I'm using the word arrow, but it's not using the vector, and that vector has some length, a squared plus b squared, and taking the square root of it. Now if you if you go from the positive real axis to the point AB on that circle, which I have just described here above, if you do that, you get that distance that is equal to the radius times phi, and if you have that radius times phi and you divide it by the radius, you get phi out of it. Now the radius times phi gives you some length, the radius is some length, and you are dividing length together, and if you divide those things you get something out of it without dimension. And that is not the case if you use degrees. So therefore we use radians, so to work with dimensionless variables. And I hope that also everybody is already has in mind that if we are working with x and y, we are also working with dimensionless elements, because x is not measured in centimeters or something, or kilometers or something like that. No, you have x and I, and it has some value, but that value is dimensionless. So it says you don't know where it comes from, and that's important. So in radians, dimensionless. Okay, then we can define the sine of the angle, the sine of phi, and that is nothing else than the y direction divided by the length of that vector. So you have along the y-axis you have the length b, and you are dividing it by the length of that radius of that circle, and that gives you the sine of phi. And the cosine of phi, that's nothing else than the x coordinate of that point AB divided by the length of that vector. And that here you have the definitions of your sine of phi and your cosine of phi. And then you can also define the tangent. Now the tangent is nothing else than in a certain sense than the direction coefficient of the line going, the direction coefficient of that line going to that point AB, and the direction coefficient you get by dividing the y direction, the part in the y direction by the part in the x direction, so b divided by a. And look, if you use the sine of the cosine, there is here is nothing. Here is staying nothing else than the sine of the angle divided by the cosine of the angle. So there you see where comes the cosine and the sine from. That has to do with the length of that vector from 0 to AB, and then you have the y direction and the x direction, and if you do it on a good way you get the cosine and the sine. Are you dividing the sine of the angle and the cosine together, you get b divided by a, and that is your tangent. So, and then that is called the tangent of that angle. Now, what's further more of importance? Now, look, if you take the sine and you square it and you add to it cosine squared, if you add them together you always get 1 out of it. Look also to the definitions, just do what is written here, and define the sine by itself, cosine by itself, and add together, and you see that you are getting 1 out of it. So so the cosine of the angle and the sine of the angle are always on the unit circle. You have there a circle with radius 1. So if you have some xy plane and you have the unit circle, so circle with radius 1. Now this has to be a circle, maybe more something like an egg, but that doesn't matter. And now what do you then have? You have some points on that unit circle, and here you can from the 0 you can go to the point on the unit circle, you get there some angle, and you see that you have that point here on the unit circle is the point cosine phi sine phi. And so you can for yourself you can remember a lot of values from the sine of pi divided by 3 and the cosine divided by 6 and pi divided by 6 and so on, by keeping in mind that the cosine and the sine are on the unit circle, and you can see a lot of things. If you look here, for instance, if you have the sine of pi divided by 3, Now then, what do I have in mind? I have in mind that unit circle, but I have an angle of pi, so this is pi, this is length pi. Now I have to divide it by 3 pieces, something like this one here. As you have here the y and here the x direction, there 0. Then you see here that you have an angle of pi divided by 3. Now, and what do I see if I let a point go down? Now I see that the distance between 0 and that point on the x-axis here is almost the same as the distance from that point to 1. And because I told you I will have a unit circle in mind, and so what do I see here? I see that the cosine of pi divided by 3, the cosine is in the x direction, so that will be 1 over 2. And because you are dividing that distance from 0 to 1 by in 2 equal pieces, so you have this one here. And then we have also that condition that sine squared plus cosine squared has to be equal to 1, and so with that you see that you have to take the sine of pi divided by 3 can be nothing else than the square root of 3 divided by 2. Here you see, add them, multiply the cosine by itself, sine by itself, and you have 1 over 2 squared plus the square root over 3 divided by 2 squared, and you get 1 over 4 plus 3 over 4, and that gives you 1, and that is 1 because you have that unit circle. And so that is okay. Now, and so you can also do a lot of those other angles by looking, keep in mind unit circle, look to the angle, and that and if you make a sketch of it, here you see that the cosine is 1 over 2, and then of pi over 3 is 1 over 2. You see it almost in the sketch, and then you have to trust yourself that it is indeed the case. Now, and so you can do it for all other kind of angles. Pi divided by 6, pi divided by 2, 0, now, and a lot of other things. Look to it, and you can calculate a lot of those cosine and sine, and later on I will give you some rules you can use to calculate those of other angles. Okay, then I will pay attention to the sine of x, this function here. What to do now? If you have the sine, I can make a graph of it. That's no problem. You see if the angle is 0, the sine is 0, and if you are in pi, you have also 0 in pi divided by 2. Look to that unit circle, then you see that the sine is equal to 1. So then you have 1, and on the other side, if you are going down minus pi, you will have 0, and if you have minus pi divided by 2, you will have minus 1. And if you have now, and if you want to have the graph of it, you get some function which goes on this way, and with a straight line through that point and goes up to, and then it goes further on, it goes down. Now, and so you go on, and so what do we see? If we look to that rule function, if you go on the x-axis, you see that function is in certain sense not invertible, because you see here, for instance, if you take some value of y, you see that you can have several points which will give you that value on the y-axis, and so you have problems with finding an inverse of the sine of x. But to get that problem away, we only, if we speak about the inverse of the sine of x, we only look to this part of it. We only look to, we specify a certain domain and a certain range, and there we will define our inverse of the tangent if we are busy. So what can we do? We can take for the domain of that sine function, we can say that we will take the interval minus pi divided by 2 pi divided by 2, so that you have, that means that the range of your tangent, so the range of your sine function becomes between minus 1 and 1. And so this we can do, we can only look to a certain point of that graph, only on that part where the x is between minus pi divided by 2 and pi divided by 2. That he only looks there. Now, let me make a sketch again. So I take that sine function and I only take values between minus pi divided by 2 and pi divided by 2, and then I have some I get some graph. Here I have 1, here I have minus 1, here I have 0, and that function here you have some horizontal tangent line, then a straight line, and then it goes again with some horizontal tangent line here. So this part we look for. And what can we now do? We can now define the inverse of the tangent. And what can we do? Now you have that line y is x. The line y is x is tangent to the sine of x if you go through x is 0. Now make a copy, mirror that graph in that line y is x, and you have your inverse function. So copy it here, and the other way we have here, and if you copy you will get something. Sorry, I got some problems with some other program and that I don't need, so that's now away. If you copy it, you get here this graph, and this function here, that is the inverse of the sine of x. So, and then I have forgotten to write down here, the blue one was y is the sine of x, and the other color is the inverse. You have the sine you have copied in the line y is x, and if you copy it in line y is x, you're changing the x and the y coordinates, and so you have the inverse function. And you see here that you have the domain of the inverse function, that will become the range of your sine function, so that becomes between values between minus 1 and 1, and the range of that function will be between minus pi divided by 2 and pi divided by 2. And so that is if you copied it. So you have I will, for the inverse of the sine function, I will often write down the arc sine. This is my arc sine of x. So if I speak about the arc sine of x, I mean the inverse of the sine function. Now, and that I want to do the domain of the arc sine function. Now arc, so ARC and then sine, that the domain of this function, that becomes the range of the sine, and that is our values between minus 1 and 1, and the range of the arcsine function, that is equal to the domain of the sine function. And so you have, for the range, you get values between minus pi divided by 2 and pi divided by 2. So here you have the inverse of the sine function. And be careful, I'm writing here the inverse of the sine function. Be careful. And I mean with that I does not mean with that minus 1 divided by the sine of x. That is a complete other function that has nothing to do with the inverse of the sine function. So I will often, most of the time, I will use the term arcsine as the inverse of the sine function. Now, and if you take your domain and your range in a good way, there is no problem. You have here defined, you have looked on a good way to your sine function, and that we can do. What do we know more about it? Now we know that the sine of the, if you let it work on the inverse of the sine, you will get x out of it. And that is because you have that is the case if you have a function which works on the inverse of that function, you will get x out of it. Now, and that you have here, you have done the arcsine is the inverse of the sine function, so then you have here. Now you can take the derivative on both sides, and let's see if we can get the derivative of the arcsine. Now we have to use the chain rule. So what do we get? We get the derivative of the sine. Now the derivative of the sine, that is the cosine function. So you get the arcsine function, the cosine of the arcsine function times the derivative of the arcsine function. And you are using the chain rule. That has to be equal to 1. Maybe I have now used, I have differentiated this equation here above to x and nothing else. And then I see here I see what I am searching, and that is the derivative of the arcsine function. Now what do I see? There, if you can write it a little bit else, you can see that the derivative of the arcsine function becomes equal to 1 divided by the cosine of the arcsine function. Okay, and now is a question from what can we do with that? What can I do with it? Now you know that the sine function working on the arcsine function, if you take the square of it and you add to it the cosine of the arcsine function, and you take also the square of it, you have nothing else staying there as the sine squared plus cosine squared, and we know that you get 1 out of it. And we know also that the sine of the arcsine function, because these are the inverse functions, that is equal to x. And so what do I see? I see that the cosine of the arcsine function, the cosine of the arcsine function, that squared, that gives me 1 minus x squared. And now I am interested in the cosine of the arcsine function, and so I have to take the square root of 1 minus x squared. And so what do we see? What do we have? We see now that the derivative of the inverse of the arcsine function, that becomes equal to now we had here already 1 divided by the cosine of the arcsine function, and if we do so, what do we have? We get 1 divided by 1 minus x squared, taking the square root of it. Now, and we see that that function is nice defined, because the domain of the arcsine function is just between minus 1 and 1, and so, and you see that that and then the minus 1 and 1 belong to that domain. But in this case, you see, if you fill in x is minus 1 and x is 1, you get 1 divided by 0, so it's not defined. So the derivative is nice if your x is greater than minus 1 and less than 1. You have no problems with your derivative of the inverse of the sine. Okay, and so we have calculated the derivative of the arcsine function. So the arcsine function itself, we cannot directly, we can say that it's the inverse of the sine function, but I cannot give you some expression for it. I can only give you some idea about how the graph will be by looking to that picture there. But if you want to calculate the derivative is quite nice, and here you see 1 divided by the square root of 1 minus x squared, and you see also that you get only positive values, and that you see also in the graph of that arcsine function. If you look at that arcsine function, you see that the arcsine function itself goes from from minus pi divided by minus minus pi divided by 2 plus divided, so it is an increasing it increases that function, so you can only have positive values for your derivative, and you see also here that you have only positive values for your derivative. Now, that is the inverse of the arc of the sine function, and now we can do almost the same thing with the cosine function. But what are we doing now? We want to also to a certain domain where we can and a range where we can define that cosine. Now, if you make some graph of the cosine function, you know in 0 you will have the value 1. In pi divided by 2 you get 0 for your cosine function, and in pi you get minus 1. And look again, if you don't trust me, look to that unit circle and look to the x coordinate of that point on the unit circle, and you see that if you start in 0 you have 1, then it goes to 0, and then it goes to minus 1. And let I do it a little bit nicer, so you have this one here. And now you can, for this part here, you can define your inverse function, and I have to shift my my graph a little bit, so here, and now and how to get that inverse function. Now again, you have the line y is x, and then mirror this part of the cosine, mirror that in the line y is x, and you will have the inverse. So you have here, you get 1, you get on that part, if you mirror, it goes somewhere here, it becomes here, and yes, that you will now, that is now you will have then you will have -1, and then that point, sorry, no, it is not completely nice mirrored, but okay. Zip. And I have to let the y-axis a little bit greater. And so what do we have here? Here we have the point pi, and here you have the point 0, and you see that you have for your inverse function of the so the arc cosine, as I call it, we have this graph here. So it is not nice, but here we have y is the arc cosine of x, or the inverse function of the cosine. So we only take a certain part of the cosine function. We only take the cosine which works on from 0 to pi, because if you work from 0 to pi, if you look to that part of the graph, then the cosine function is decreasing. So you have it is injective. It is also surjective on the on the part -1, and you can and then you know from if those two things are good, the inverse function exists. Now and you can see the people by mirroring that function, that part of the cosine in the line y is x, how the inverse of the cosine looks, and you have your inverse of the cosine. And now yeah, what is the domain of the arc cosine of x becomes the range of the cosine, and you know the range of the cosine is between -1 and 1, and so the range of the arc cosine, that is nothing else as the domain of the cosine of x, and the domain, we took the part from 0 to pi, and so you have the domain is your interval -1, 1, and your range of the arc cosine are values between 0 and pi, and that they understand by that arc cosine and the arc sine of x. Now I have done this cosine. It looks a lot on that of the sine of x, so that is not so problem, and therefore now because I am already a half an hour busy, I want to start a new file, otherwise those files become too big. Let's go to the next file.